All right, welcome to another video on solving quadratics. This time we're going to be focusing on another algebraic method. Again, there's two main methods, solving and algebraically. I'm sorry, graphing and algebraically. So the solving by graphing, like I said in the past, it's pretty easy to do as long as you have the right graphing utilities and materials. If you don't have graph paper, if you don't have a graphing calculator, I would not solve by graphing. Or if they don't give you a graph already in front of you where you look for the x-intercepts. Solving algebraically is going to be your go-to most of the time, unless, like I said, you have those things. There's four different methods. We already learned about factoring. You set it equal to 0. We learned about square roots, and today we're going to be going into how to solve by completing the square. The last video was about completing the square, how to complete the square, but now we're going to use that information to actually solve. All right, and then what's going to happen is basically you're going to start with a quadratic that you cannot solve by square roots. You're going to turn it into something you can solve by square roots by completing the square. So this process will make the problem into this type of problem. So if you haven't seen the video on solving by square roots already, I suggest you go back, take a look at that one. That way you understand what's going on when we get to that step. The last video was about completing the square, the visual with the algebra tiles. Today, like I said, we're going to be solving by completing the square. A few different steps here. First step, you're going to isolate your x squared and x terms on one side. That will make it like the problems that we did on the worksheet in the previous lesson. Step 2, you're going to complete the square. That's where you divide by 2 and square it. There's going to be a little bit difference here because you're not going to add it just to one. You're going to add it to both sides since you have an equation. After that, you're going to have a perfect square trinomial, in which case you can use the pattern to factor it. And then fourth step, this step is actually, like I said, it makes it into so that you can solve it by using square roots. So again, if you haven't seen that video, please make sure you go back and watch that video. All right, so let's put these steps off to the side, and I will do 2 examples. And then I'm just going to follow along these steps, so feel free to get the worksheet on a separate screen or print it up if you want to, or write it on a separate piece of paper. But feel free to work along with this just so you can see how to do this, okay? So first step, go ahead and isolate the x squared and x on one side. So I see my x squared is right here. I see my 8x is right here. I don't want this plus 3 because I need these two pieces by themselves. That way it looks kind of like the worksheet that we did on the previous lesson, okay? So this plus 3 I need to get rid of. So how do I get rid of a plus 3? I subtract 3. So I get x squared plus 8x equals 7. If I ignore this equals 7 part and I just take a look at this left side, this now looks like the worksheet that we did when we were completing the square as a process. So what I do is I do the whole framework of completing the square. So that's dividing by 2 and then squaring it. So I take this number in front of the x, which is an 8. I divide that 8 by 2 and square it. And that's going to tell me what I have to add on to here to make a perfect square trinomial. That way I can use the factoring pattern to factor that thing. So 8 divided by 2 is a 4. 4 squared is a 16. That is what I'm adding on to here. So I got to add a 16 to the left. But since I have an equation, I have to add it to the left and I have to add it to the right because I have to keep this equation balanced. None of these are like terms. So I'm just going to rewrite x squared plus 8x plus 16. 7 plus 16 is a 23. All right, so just ignore this 23 for now because what I did was I made a perfect square trinomial. And every single time you do completing the square, that's what you're actually trying to do, is make this so that I can factor this thing out. So the square root of x squared is x, square root of 16 is a 4. So it's just going to be x plus 4 when I use my pattern. X plus 4 squared equals 23. So this thing turns into this, all right? That's the whole point of doing that, is you don't have to factor. You can just go ahead and use that pattern, make it nice, neat, and quick. From this point though, that's step 3, super fast, you just factor. Step 4, now you're gonna solve. So this goes back, like I said, to the previous video of solving by square roots. So to get rid of a squared, since this entire group is being squared, to get rid of a squared, you square root, but what you do to one side, you have to do to the other side. Squares and square roots cancel off, and then just make sure you put your plus minus on this 23, okay? All right, so, and now this problem's basically, we've done these problems already in the previous, I think 2 lessons ago. when solving by square roots. So now you're just going to split into two equations. Square root of 23 does not simplify. 23 is not a perfect square. I can't take any pairs out, so it just stays square root of 23. So now just isolate your x, subtract 4 from both sides. Now you can turn this into a decimal. Square root of 23, plug that in the calculator, then subtract 4 from it. You'll get some decimal answer. You're going to have to round off. But most of the time, you're going to be asked to give what's called the exact answer. What the exact answer means is if there's a square root that doesn't become nice and neat, you just leave it like that, okay? Normally, you want to write this -4 in the front and then your root on the right side, because if you put the -4 on this side right here and you write very sloppily and then the square root extends, it's going to look like this -4 is under the square root when it's not. So go ahead and just write it so the -4 out front, the positive 23 in the back, and that's it, okay? And again, you could always put this in a calculator and get a decimal, but just depending on how it asks for the answer. This other side, same thing, subtract 4 from both sides. Again, these two are not like terms, so don't put them together. Don't make this like, don't subtract 4 from 23. That's not going to work. It's under a square root. So just leave them separate, put your -4 and -23, and that's it. All right. Basically, that's putting together a few different days of lessons. I'm going to do one more example just so that you can kind of get this understood. Feel free to try this example on your own first before you watch the video. Or if you're working along on your worksheets, feel free to try your worksheets out. I'm going to go ahead and go through it though. So first step, isolate your x squared and your negative 10x or minus 10x by adding 9, because I don't want this here. I want to start off with kind of like clean slate to complete the square. I just need these two parts to complete the square. So add 9 to both sides. I got x squared minus 10x equals 39. I'm going to take that -10. I'm going to complete the square with this side over here. So -10 divided by 2, square it. That's your frame that you want to put in for your completing the square. So throw a -10 right there. -10 divided by 2 is a -5. Square the -5, you get a 25. That's what's telling you you should add to both sides. You have to add to both sides because it's an equal sign, okay? Don't just do it to one side, do it to both sides. So you get x squared minus 10x plus 25. 25 plus 39 is 64. This is now a perfect square trinomial. So 5 times 5 is 25. X times x is x squared. You get a minus sign, so x minus 5 squared is the factoring pattern. Okay, x minus 5 squared equals 64. And now you just solve. So again, you have a squared. Opposite of squared is square root. Squares and square roots cancel. You get an x minus 5 equals plus or minus the square root of 64. I'm going to go ahead and split these into two parts. Now 64 is a nice neat square root, so you probably could have taken it up here. That's a plus or minus 8, and then just put 8s down here, but either way, it's fine. You get the same answer. So square root of 64 is an 8. Subtract 5, so you're going to add 5. You get a 13. Same thing here, but it's not a positive 8. It is a negative 8. Add 5, you get a negative 3. And that is all. So that's how you solve by completing the square. It's a kind of lengthy process. Quadratics are probably one of the more difficult things in Algebra 1s to do. But if you follow this and you practice, it should become more easy the more that you try it. You're bound to make some small mistakes, but that's part of learning. So feel free to give me a loop mail or come by during my office hours and I can help you out more if you keep getting tripped up on anything, okay? I hope everyone's doing well and take care. Bye-bye.